Hello, it's James Rashford. I am here to talk to you today about science, and just a little bit of science. We're not going to go into a big lecture, but I want to talk to you about two basic principles. One is parsimony, also known as Occam's razor, and the second is just the nature of truth and how knowledge changes over time. So let's start with parsimony. So, it's a fancy word, nice sounding word. I really like the sound of the word. It means that when you're looking at how to explain something and you're faced with multiple different options for explanations, the choice of explanation that is most likely to be correct is the one that requires the fewest assumptions. And again, this principle is known by two names, Occam's razor and parsimony. They both mean the exact same thing. It's both the same term. So, for example, let's say that we're trying to figure out what happened to your chicken. You've got chicken coop in the back, and one day you go outside and there's no more chickens. So we could have a couple of different possible explanations for what happened to your chickens. It could be that your chickens wandered off. Let's say the gate was open, and that might lead to one suggestion is just that your chickens wandered off, but another option is that aliens from outer space came and abducted your chickens. And a third option might be that some malicious actor, another human being, came and stole your chickens. So we're going to look at these three options, and we're going to look at them and apply the principle of parsimony or Occam's razor to them. And if we look at the first option, chickens just wandered off, well, the only assumption that we need there is that somehow the gate was unlocked at the time that the chickens wandered off. We have the evidence of the gate being unlocked and the fact that it is unlocked now. So it's not a very big stretch to say, okay, the gate's unlocked now. It's a reasonable assumption that the gate was also unlocked at some point in the past. So we have not a lot of, we don't have a lot of conclusions to jump to. We don't have a lot of assumptions to infer in order to go from the chickens are missing, the gate is open, to the chickens wandered off. But let's look at the other option. Aliens came down and abducted my chickens. Well, there's actually a lot of assumptions built into that. So first off, we've got the assumption that aliens, space aliens, exist. That's actually a pretty big assumption. And then our next assumption is these aliens who exist came and visited not just Earth, but my backyard and my chicken coop. And then another assumption is that these aliens who came and visited my chicken coop somehow did so while escaping my observation. And then for some reason these aliens wanted chickens. That's actually an awful lot of assumptions. So that theory of why the chickens are missing is really not going to pass the principle of parsimony. Now there's this other option among our set of principles here. We've also got the option that some malicious actor, some person, came along and stole the chickens. And I can concede that this is a possibility that we really might want to consider. Even though the principle of parsimony doesn't dictate that this is necessarily the best choice, it's really about on par with the chickens wandered off on their own, because it doesn't require us to assume that the gate was left open. In fact, we can assume that the gate was left closed and that didn't stop a malicious actor from coming and taking the chickens. So really, I'd say that the malicious actor theory and the chickens wandered off theory are actually about equal under Occam's razor or the principle of parsimony. I would say that I would personally be more inclined toward the chickens wandered off theory, because it's still an assumption that there exists a malicious actor who wants your chickens. But again, it's not a hard assumption, because chickens are great. I mean, who wouldn't want chickens? So really all you're assuming is that there's somebody who knows about your chickens and has no moral qualms about taking them. So parsimony doesn't really help us completely solve that problem, because it still leaves us with several possibilities. And that's really akin to what happens in real science. When we come down to different hypotheses as to what could explain something, we often have multiple options that are really about equally plausible. So parsimony will help us to rule out some possibilities, but it doesn't always solve the problem for us. And there have been examples in history and in the history of science where the principle of parsimony suggested an answer that was wrong. One example I can think of off the top of my head is the spontaneous generation of life. Once upon a time, nobody knew where life came from. We didn't understand DNA and the continuity of life with organisms reproducing. And there was an observation that if a bowl of water is left out indefinitely, that over time it'll start to grow moldy. So it led to the assumption that, well, life just spontaneously erupts in bowls of water. That's just how life works. And that met the principle of parsimony at the time because it didn't really require a lot of assumptions. Now, it turns out that with further experimentation, we were able to further narrow the details of that. We were able to find through experiments that covered the bottles of water versus leaving them open, and other experiments that figured out the nature of life, we were able to find that there were actually microscopic spores traveling in the air that actually landed in that bowl of water and caused things to grow in there. So we now know that there's actually a more complicated mechanism going on causing bowls of water to get moldy than what we originally assumed. So parsimony doesn't always get us to the correct answer. But the reason I'm talking parsimony today is we've got a lot of conspiracy theories going around. And, you know, when it comes to the COVID-19 conspiracy theory, it seems like a lot of these conspiracies say some nefarious actor is doing a weird thing for a rather unclear motivation. They are overstating the deaths to get political power. They are misrepresenting the immunity, or they're overstating the contagion to control us in our homes. All of these ideas are going around when there's this competing idea that they are doing the best they can with the information available, and the numbers are what they are because that's the best measurement we have available. And the people who are telling us what to do are making their best guess as to what is going to work. Now, again, applying the principle of parsimony, what does the conspiracy theory require? The conspiracy theory requires a number of assumptions. We need to assume malice, first off. We need to assume that these actors are malicious and trying to hurt us. We need to assume that they have a particular goal in mind, which means we need to narrow down that goal, which we can't get to without making an assumption because we don't have evidence for that. We need to assume that they have this coordination that is happening in secret because we don't see evidence of it. So there's a lot of assumptions that we have to make without evidence with conspiracy theories, that if we accepted the principle of parsimony, it would be a lot easier to understand that, look, things are what they seem. What is going on in face value is probably what is going on in reality. So that's how the principle of parsimony applies to our current situation with COVID-19 and all of the conspiracy theories that are going around. Now, the second principle of scientific knowledge that I want to tell you, and again, most of you already know this, but this is just a reminder for some people who don't really have a full understanding of how science works. One critique of science that I saw recently was, the scientists, they're telling us different things all the time. First, it was one number. First they said it was millions, then they said it was 60,000, now they say it's 120,000. So what is it? How can we trust science when the numbers are always changing? Well, it's the nature of science that as information comes in, you adjust your belief, your view. And that is partially one of the key distinctions between science and other methods of knowledge, like deference to authority or religious faith. The nature of science as a belief system, as a way of knowing things, is that it is flexible and that it is subject to reception of evidence. So the reason that the numbers are changing, the reason that the recommendations are changing is more information is coming in all the time. And scientists and scientific people allow their viewpoint and their recommendations and their knowledge to be adjusted as new evidence comes in. So that doesn't mean that science is unreliable. It means that science is operating correctly and that scientific people are doing what they're supposed to do in terms of applying new evidence in order to come to different conclusions. So the nature of science is not a matter of committing to a belief in an absolute fact. In fact, really, most scientists will tell you that we don't really have a lot of absolute facts. We don't have a lot of, absolute truths. Scientific truth, by its very nature, is subject to new evidence, subject to change as more information comes in. And that's really the core of the scientific method is something is scientifically true if it can be independently proven in multiple experiments or multiple similar observations from independent people. And something can cease to be scientifically true when more information comes in that proves a different mechanism is going on. So just because something is a scientific truth today doesn't mean that it is the absolute truth. Science is a continual process of improving knowledge. So that's my little 5-minute, 10-minute, I guess, spiel on science today. Share it with your friends, and we'll talk more tomorrow. Thanks.